Hi everyone, welcome back to Workshop, and it's project time again. This is my Maynuo M9811 200 watt DC electronic load, and I wanted to make a little bit of a project out of this one by modifying it, hopefully to the 300 watt standard, i.e. the M9812 model. And I'm going to be doing this by tearing this thing apart, adding in the extra components necessary in order to upgrade it to the same spec as the 300 watt model that you can buy. Hopefully it'll work, but let's tear it apart, let's take a look inside, and I'll show you what the road is ahead. So I do actually have another electronic load, so I'm not so worried about making a sacrificial lamb out of this one here. But looking at the circuit board and looking at the pictures of the 9812, the 300 watt model online, I think they share the exact same circuit board. And as you can see, there is space here for another heatsink, some more resistors, and a few more MOSFETs. It even actually has the header down here for the fan, which is in a slightly different position to this one over here. So I'm thinking it's either going to go one of two ways, i.e. I'll fit the components in place, the heatsink, the resistors, the MOSFETs, and the software in the microprocessor will detect those are fitted and automatically enable the 300 watt option on the display panel, which is currently limited to the 200 watt. Or I'll go to the trouble of fitting all this extra hardware only to find that I'm still limited to 200 watt on the front panel. But out of curiosity, I can't resist making the modifications just to see what happens. And if worst case comes to the worst, I just leave everything in place or remove the MOSFETs, and it's back to the 200 watt spec hardware. So the biggest problem I actually have is the heatsink itself. This is custom made heatsink. It's actually two heatsinks that are interwoven in terms of their vanes and slid together in such a way that it tunnels the airflow from the fan right out the back on the output here. And finding something that could replicate that, I mean, I've got any amount of heat sinks in stock, but they're all your typical one-sided heat sink. There is nothing enclosed about them, and I can't afford to have any of the hot air that may be generated to make its way inside the enclosure itself. It must be tunneled out the back. So what I did was I actually contacted Maynuo, the manufacturer, and just sent them an email, asked them, do you have any spare heat sinks or any that I can buy, any old ones lying around or brand new ones willing to pay? And they said, sure, we've got one, all you need to do is pay the shipping and you can have it for nothing. And here it is. Now it's obviously a second-hand one, as you can see. It's got some rather large burn marks on the side there. Yeah, but it's even comes complete with the fan, so I didn't need to source one of them myself. So, yep, a little bit of a clean up there, and I can use this. It's got all the holes in the right places for mounting it onto the PCB, for mounting the MOSFETs. We're good to go. The next thing was the actual MOSFETs themselves, and you can see them down there. You've got 1, 2 there, and there is actually another 2 on the other side down in there. Yep, you can see them, and they're all the same, and they're just off-the-shelf MOSFETs, and I was able to pick up a few of them from my normal supplier, so we're good to go with them. This side also has a transistor and a bridge rectifier. This side doesn't have that. All you've got is a heatsink and the 4 MOSFETs. and I believe there is actually space down here for another component. Not sure what it is. It could be just a diode or something like that, a TO220 mounted diode, but it's not fitted on the actual 300 watt spec units that I've seen. And the only other thing to fit is 4 large resistors. I think they're 8 watt on the 200 watt model down this side. So I've managed to pick up some 5 watt ones, which will do for a kickoff, and we can fit them and see how we go from there. The only other thing I need is a 2-pin Molex style header. I've got plenty of them in stock, and we should be good to power up after that. Now the heatsink doesn't mount directly onto the PCB. That would be a bit of a disaster if I did that. I will need to put some spacers on. The other heatsink down there is actually raised off the circuit board, I think by maybe about 2 or 3 millimeters, something like that. So I've got the necessary spacers for that. And if I turn the enclosure over, you can see this is the mounting arrangement for the heatsink that's already fitted, and I've got any amount of holes over that side for mounting the new heatsink. So first things first will be to clean up this mess on the side of this heatsink here, and then I think mount the transistors to the sides of the heatsink so that it can basically just drop in and straight through onto the PCB. I will need to clear the solder on the holes of the PCB because they're all filled. I'll do that and then we should be good to go from there. Now this burn mark here is really quite rough, so I'm probably going to have to use sandpaper to clear that up, because these 2 outside holes here are actually used to mount the MOSFETs, and this one's a little bit too close for comfort, so I'll rub this one down and see if I can clean that up a bit. Ah yes, that's coming away quite quickly actually. And there we go, that'll do nicely. So next thing, let's go mount the MOSFETs. Okay, let's have a look through my insulating kit stock. Yep, I think we'll use these. Yep, and I don't need any of the top hats because the actual MOSFET itself, it's got an insulated tab. So there's no chance of the screw actually shorting the tab to the heatsink. There we go, got the hardware I need, so let's bolt them up. Now yes, I am doing this completely without lock washers. I've just got 0 stock of them right now. Keep on meaning to order them, but never get round to it. Okay, MOSFET's in place. Now I need to take a look and see what size spacers I need in order to get this off the PCB. Okay, next thing I'm going to have to do is remove the PCB, because I do need to do some soldering obviously on the underside of that PCB, but the bottom panel's not removable. So I'm going to have to undo the screws that hold the PCB and the existing heatsink in place and hopefully slide the circuit board out. And you can see the underside there, and you can see that there's actually round transpillers that go down through these large holes here, directly mounted onto the heatsink, which will then directly mount onto the bottom of the chassis. And there is actually another couple of screws there that will be mounted via spacers onto the underside of that heatsink. Okay, well, here's the first problem. If you look at the PCB, I thought these pillars here were mounted directly onto the heatsink, threaded down through, but if you look at the heatsink itself, it's only got these two holes here which correspond to those two there. This is one big plastic assembly, so obviously those don't directly attach to the heatsink, only these screws here do. So I thought, well, how am I going to mount this side here? And I thought, you know, I'm going to do exactly the same. So I've 3D printed a couple of more or less identical mounting arrangement there. So basically, this will go through the hole here in exactly the same way, and this here screws onto the heatsink here. And what it also allows me to do is I've 3D printed these with an M4 thread on the ends of those pillars there to replicate those ones, so that they can use the same screws on the underside of the base of the unit there. So I've 3D printed two of them. We're all ready to mount the new heatsink onto here. But first of all, I will go and populate all the various resistors, the two different sizes, and also the connector for the fan. So let me go away and do that now. And one thing, I couldn't actually find suitable 8 watt 0.05 of an ohm resistors, the same as that side there. I could only find 0.1 ohm 5 watt. So I'm going to put two of them in parallel. That'll give me the power I need and the resistance. Right, that's the 0.1 ohm resistors fitted, and there's 4 220 ohm resistors, quarter watt, and I've fitted a two-way header. Not the right type. I don't have a two-way mounting one that matches up with the connector on the end of the fan, but this will have to do. It works, so that'll do. So I think now I'm ready to mount the heatsink. So let's give it a bash. So I've reorientated the fan so that the cable comes out the right side, because it was meant to be the other side. Now I might need to loosen these screws to get it to line up the legs of those MOSFETs, but we'll give it a bash. And that's it, I believe. Let's turn it over. Get it down. So, yes! Seems to line up nicely. I can now see the threads on the heatsink down through those holes there. What I will need to do is bolt it down, get everything tight before I do any soldering. So let's get some screws and get them screwed in. And yes, the heads of the screws do clear the tracks. Not much clearance, but it does clear. Nip them up. And that's it tight. Let's take a look at it. Yeah, and we do have a gap right along there, same as on the other heatsink. Right, I think I'm ready to solder up the MOSFETs. Now I do have to actually slide it back into the base purely just for the connectors, because the tails are really short, unfortunately. Okay, there we go. I think I've reassembled enough for power up. Transformers in, got all the connections in the back, they are done. All the screws are fitted on the underside, mounting everything down. I've got an earth wire connected here temporarily. Fans are both plugged in. I think I'm ready for a power up. So let me reposition, ready for a power up. Right, here we go. Self-test. Well, it's powered up. And no magic smoke. And we've got a good display. Now, what I was hoping is that the firmware in here is the same for both models, but it would auto-detect perhaps the second bank being fitted, would automatically allow you to set a 300 watt limit on the current without any recalibration, and perhaps it would run at 300 watts, but I've got no idea. I'll power up again and I'll check that limit. Whether I need to recalibrate it or anything like that, I have got absolutely no idea. I won't know that until I put a load through it. At the moment, of course, no load. So power back on again. It's a pity it didn't give some sort of status on the display. So let's check, see what the power is set to. Okay, it was already set to 200 watt before. Let's double check. I can go down the way first. 150, enter. Yep, 150 watt. Now let's see if I can go to 250. No, the limit's still 200. That's not good. Maybe I need to recalibrate. I don't even know how you recalibrate it. I'm sure you can do it from the front panel. Well, as it looks like, I can't change the 200 watt limit to 300. And I've been over the entire PCB looking for links or optional resistors or some kind of selection grid for possibly selecting 200 versus 300 option, and I can't see anything. The only thing I have found is there's a resistor down here that's missing, and looking at some photos on the web of the 300 watt model, that resistor down there is populated. However, that's too close to the MOSFETs to have any sort of impact on the processor, you know, possible selection of the software. So I don't think it's got anything to do with that. So I'm going to leave that alone for the time being. Now there's a couple of things I've noticed. There is actually a small header here. Let me zoom in. So I think I've worked out what this three-way header is for next to the microprocessor. This pin here is ground. The other two pins here go to two pins on the actual microprocessor. Now one of the lines is actually a reset line, but it also doubles as a debug clock pin. The other pin itself is the data on that debug interface. So I think those two pins are used for programming the 8051 according to the datasheet for the microprocessor anyway. Now the question is, what has happened to the calibration if I power up and just simply load up a power supply on my workbench? Am I going to get the right readouts here, or is somehow adding in the extra heatsink, MOSFETs, resistors, etc. going to affect that calibration? Well, we're about to find out. So I've set it up for a 1 amp load. I've got it connected onto one of the power supplies of my workbench, set at 12.3 volts. That's reading correct. And it's a 5 amp power supply, so we'll start off at 1 amp. So let me just... we're all ready to go. Let me just turn it on here and see what happens. Well, yes, 0.9995 amps. And it's reading 1 amp on the power supply. So the calibration's intact. So let's go up to 5 amps now. It's 5 amp power supply. I think my leads are heavy duty enough for that for a short period of time. There we go, 5 amps, and let's go. Yep, 5 amps on the button and 12.027 volts. No problem at all. 60 watts. Perfect. Now one thing I'd like to do is try and verify that that second heatsink is doing something. So without probing the MOSFETs to find out if they're turning on or not, I think the easiest way to do it is I'm running it under load here. I'm running it on a 1 amp load on my bench power supply. It's been on for about a couple of minutes. I'm going to put the thermal camera onto this bank of resistors and MOSFETs there, and let's have a look and see if we're getting temperature on both sides, or maybe just on the original side. I don't know. The fans haven't kicked in yet. I do have it open case at the moment. I probably need to put in a much higher load to see the fans come on, but we'll try the thermal camera and let's just see if anything is showing any kind of temperature rise. Well, I've upped it to 100 watts, and yes, we're definitely getting those MOSFETs heating up. In fact, you can see the temperature down the side there, and both sides of the MOSFETs down the outside sides of those heat sinks are starting to... oh! And this fan's running on the new side, but the one on the other side not running. Yep. This one's running as well now. I did kick start it, but I don't know if that was coincidence or whether there's a problem with that fan and it just took a little bit of a kick start to get working. Let me stop it. Ah! We've got a problem with that fan. Wow. But yep. Does look like we're sharing the load at least on both of those heat sinks and MOSFETs. All I need to do now is just get the 300 watt limit enabled. So where do we go from here? Well, to tell you the truth, I'm gearing towards a microprocessor. I'm gearing towards modifying the hex in that microprocessor to possibly reset a 200 watt limit to 300 watt. Maybe it's as simple as finding a 0200 string in the hex that I can simply modify to 300. I can also download the flash contents of that microprocessor, and maybe there's something in there as well. Now, it's an 8051 based microprocessor. My Datamin 40 Pro is well capable of reading both the flash and the ROM contents, I believe, so perhaps we'll go down that route next. But I think that'll be for a second part video. Quite keen to see what you guys think down below about the possible direction we can take now. Thanks for watching.